So we are going to draw or point a square root of 2 on this number line, and here is 0 and here is 1. And I'm assuming that you already know how to draw a line perpendicular to a given line or line parallel to a given line and midpoints, etc. So first, let us go ahead and draw a perpendicular line here. So here is a perpendicular line, and now what we do is bring our compass and then just put the pointer here at 1 and then stretch it to 1 unit and draw a circle. So here is a circle, and if you look at the point of intersection here, this is 1 unit in length. So what we just got is that that we shall just go ahead and connect these through a segment, and then we have a segment of length 1 right over here. So what we have now is a right triangle with each of the legs equal to 1 unit. So by Pythagorean theorem, this hypotenuse will be a square root of 2 units. And now you can go ahead and take this origin as the center and this segment as radius, and then draw a circle, okay? And the intersection of this circle and the line would be the point square root of 2. So we can just go ahead and mark. So this point here as a square root of 2 on the number line. So we got a square root of 2. Let's go ahead and erase all the material that we used. So here we go. We will just erase whatever we don't need now. So here, let's just go ahead and remove these as well. Okay, this one as well as this one. Okay, and then now say we would like the point square root of 3 on this line. What we got to do is draw a perpendicular line and then draw a circle of radius 1 with center here at square root of 2. And what we shall have is that, let me just get rid of this perpendicular line. So we have this is a line of length 1. We don't need the circle anymore either. Okay, so, and now what you have is this. You have another right triangle. All right, and for this right triangle, we got this leg is a square root of 2. This is 1. So what will happen? This hypotenuse will be square root of 3. So as before, the way you had gotten a square root of 2, what you can do is just go ahead and take this as center, this as radius, and just make a circle. And here you got a square root of 3 as intersection of the number line and the circle. So again, what we will do is that we shall just remove most of the things that we don't need, and whatever we wrote by hand, we can just go ahead and erase them. Again, only what we don't need. Okay, and so we know that right here this point is square root of 3. And we can just go ahead and just for fun, let's notice one thing. So say we, on this perpendicular line, we get a segment of length 1, and then what we join these 2 points. Okay, then what will happen? We have this, and again we are doing it just for the sake of just demonstrating this, that this length is square root of 3. This is 1, so this would be what? Is square root of 4, and that is 2. So remember this length was 1, this is 2 right here. So if we make a circle with center at the origin and radius, this is going to pass through 2. So this is the way we got 2. Of course, we did not need to obtain 2 this way. It's already available easily on the number line. So again, I'm going to just go ahead and clean the slate here. Okay, that is just erase. Just go ahead and erase the things that we don't need anymore. All right, so here what we had a square root of 3, and here we have 2. Now the question that you had asked was that how to draw a square root of 3.5 on the number line. So a way we can go about this is this, that first notice 3.5 is 35 over 10, which will be square root of how much? 7 over 2. Now if we rationalize the denominator, what we will get is square root of 7 times square root of 2 over 2, and that is square root of 14 over 2. So what we will do is that we will try to get a way of constructing a square root of 14 here on the number line, and then we will take the bisector of the point between the origin and this value. So for a square root of 14, one way is this, that if you look at, if you want to extract a perfect square from this as a sum and then write the remaining portion, you can write it as 4 and 10, all right? But or another approach is this, and this is what I'm going to take because we got the material for that already here. That is, this is one way, this is another way, and there can be many more ways. Okay, so when you write 14 as 9 plus 5, okay, then what you have is, so now you can write 14 as how? 3 is square plus square root of 5 is square, right? Okay, so let's construct a square root of 5 the way we did the things before. That is, we will go ahead and make a perpendicular line, okay, and then take a segment of length 1 and then just go ahead and make a number line. So this would be what? Square root of 5. All right, and so here we got a square root of 5. Now we will make a perpendicular line again, and this time we will do what? We'll take a length of 3, and then if we just go ahead, so actually I'm just going to make it again for you. So 1 second. Let me just erase this all. So I just practically, so this is a square root of 5, and then we have a length of 3 here, and we will go ahead and then just draw a circle properly. So we will draw a circle with this as center and a square root of 14 as the radius. So here we got the point square root of, square root of 14 at the intersection. So here we have a square root of 14 right here. So all we have to do is just go to the midpoint, which is right here. So this would be square root of 14 over 2, or in other words, so here we have this as a square root of 14 over 2, and which you saw was what? Simply a square root of 3.5 that you asked me for. All right.